Hi everyone, this is Pavitra, working as an assistant professor in Sri Muthukumaran Institute of Technology in Biomedical Department. We will continue with the Assistive Technology Unit 3 lecture video. We have already seen about these course objectives and contents and course outcomes also. So, we are directly going to see the DSP in hearing aids, digital signal processing in hearing aids. In hearing aids, signal is processed using this DSP block. This is the detailed block diagram of DSP system. Now we will see one by one about this block. First, acoustic signal is converted to the electrical signal by microphone in the first stage of the hearing system. After this conversion, a frequency filter is introduced to reduce possible distortion in the input signal. Usually from outside there is many chances of distortion, so we are using the filter to filter out the noise and reduce the distortion. Then the signal is sampled to the given number of times per second. Usually the sampling rate is 10,000 times per second, or it will be greater than that. The analog signal is then converted to the digital equivalent by the analog to digital converter. Each sample receives a digital code. Binary numbers, zeros and ones, are used to represent the digital values of the each sample. Following the digitization of the signal representations are processed by a CPU or microprocessor. The digital values can be multiplied, added, divided and subtracted and grouped into defined ways. In the microprocessor, various algorithms will be available. An algorithm is a set of rules to operate the manner determined by the set of mathematical rules and equation. If the algorithm is dedicated one, it performs specific task to process the input signal. For example, one algorithm may control the frequency response of the system. Another may control the loudness growth, and third algorithm may to enhance the speech signal in a background noise. And for each specific task, separate algorithm is assigned and the tasks are performed simultaneously. After the microprocessor has performed its task, the digitized signal must be converted back into the analog equivalent. This is accomplished by the digital to analog converter. This will be done in the DAC stage. When the digitized signal is converted to analog stage, it is frequency filtered again to prevent the signal distortion. Before signal processing also frequency is filtered, and after the signal processed it also again frequency filtered. It is then amplified by the conventional manner and submitted to the receiver, that is speaker of the hearing aid. What are the advantages we have when using this DSP hearing aid? Signal audibility, we can clearly hear the signal. Compensation for loudness recruitment, and compensation for excessive masking. Reduction of internally generated noise, we can filter the distortion. Automatic control of hearing aid performance, the system will be controlled automated by the central processing unit or microprocessor. Improved performance with the use of conventional telephones and cell phones. Physical size. The main advantage of this DSP processor system is chip size is smaller, which is most important for the hearing aid development. So most of the people will prefer this kind of DSP processed hearing aids, since DSP chip is more efficient. Greater acoustic gain is possible without increasing the physical size of the hearing aid. Thus the DSP technology, greater losses can be accommodated without sacrificing its performance. This is the physical size of the hearing aid, which is used the DSP processor system. There will be some limitations in the DSP processing system. DSP systems do not separate the noise and the signal, although such would be most desirable. We cannot separate the signal and noise, but we can desirably convert the signals. DSP signals may not always be the most appropriate instrument of choice for all levels of hearing loss impairment. Thank you.